Find the partial fraction decomposition for the integration of this expression here. So if we read the question carefully, they just want the partial fraction decomposition. So we really just need to learn how to, or demonstrate how to rewrite this rational function here. Right? But they're just mentioning partial fraction decomposition. You use that when you're integrating. But no one, if we read the question carefully, no one's actually asking us to do the full integration. So we will stop as soon as we can say, oh yeah, this thing is this plus that plus this simple fraction and so on. Okay. So let's take a look here. We've got, it was 9t plus 4 over t squared minus 2t plus 1. All right, just go on a double check. Always double check that you've copied things down right. Yep, looks good. Looks perfectly fine. So we're ready to actually continue on. Now, when it comes to partial fraction decomposition, the first thing, as always, that you should look for is the denominator, that polynomial on the bottom. How can it be factored? Can it be factored at all? Or is this an irreducible quadratic that can't be split up at all? Now, depending on your experience with math, you might immediately recognize, like me, I've done a lot of math, as you can imagine. I immediately recognize this is t minus 1 squared. Okay? But you might take a little bit more time to factor it. You might say, okay, we need 2 factors. If it's going to factor at all, we need 2 factors. We'll have a t here. Can we think of 2 numbers that multiply to 1 and add to negative 2? Yeah, oh yeah, minus 1, minus 1. Oh, okay, it's the same factor. Okay. If you recognize that it's t minus 1 squared off the bat, don't waste your own time making a show of it. But there we go. If you needed to factor it a little bit, you should always want to be up on your factoring skills so you can do something like that. Okay, so what this really is minus 9t plus 4 over t minus 1 squared. So we have we don't have 2 factors. We have the same factor twice. We have the duplicates. We have a repeated factor, right? So it's a repeated linear factor, t minus 1 squared. So what's the decomposition that you use when you have a repeated linear factor? A over, so for each factor, starting with t minus 1 to the power 1, all the way up to however many you actually do have on the bottom, in this case 2, you introduce a new partial fraction. If it was cubed, just to help illustrate the point, if it was cubed, we'd need 1 more. If it was to the 4th power, we'd need 1 more. You'd just keep going like that. Now it's only t minus 1 squared. So we just go up to these, and now we just have to find what are the constants a and b that make the left-hand side equal to the right-hand side. So that's setting up the decomposition, but we're not done the question until we have the a and the b here. Okay. So what I would probably do, I'd multiply both sides by t minus 1 squared, because that will leave you with just the numerator over here on the left. If I multiply by t minus 1 squared here, one of those factors cancels out a little bit there. And then multiplying by t minus 1 squared with this one, they actually cancel out. You're just left with b. Okay. So one thing we could do, we could plug in t equals 1. For example, you'll get minus 9 plus 4 is equal to a times 1 minus 1 plus b. And then 1 minus 1, the reason I said t equals 1, that'll be 0. You'll get 0 times a. Who cares what that is? Minus 9 plus 4, that's minus 5. That's equal to b. Now, we'll write it over here. So you get b. B is minus 5. Okay? Now, that's not the only way you could have done that, but it's definitely the way I prefer, is to try and plug things in. Okay? If you can. If you got linear terms, because you can always find a root for or 0 of a linear term. Okay? So that's what b is. How do we find what a is? Okay? How do we find what a is? So I've got minus 9t plus 4 is equal to a times t minus 1 plus b, but b is minus 5. So we can actually plug that in. What I'm going to do, I'm going to expand this out. I'll have a times t minus a minus 5. And there we go. And now these two are polynomials. They're polynomials in t. They've got constant terms. Constant term over here is minus a minus 5. That constant term has to match up with 4. And we can actually rearrange that, so we can figure, okay, add 5 to both sides, and you can figure out a is minus 9. Or you could say, look, they both have a coefficient of t, Polynomials, and this is a fun fact that we can exploit, polynomials are only equal if all their coefficients match up. So that would be another way that we could see a is minus 9. So there's actually two ways we could approach it, but either way we get a is minus 9 from expanding and comparing coefficients, which is a great other approach that we could use. So either way, we've done it. We found our a, we found our b. So we got minus 9, we got minus 5. That's the decomposition we need. So here we go, minus 9t plus 4 over t squared minus 2t plus 1 is minus 9 over t minus 1. One thing you got to watch out for, make sure your a matches up with where you originally wrote it. Otherwise, you've got the wrong decomposition. Then we'll say plus minus 5 over t minus 1 squared. So there's the decomposition. We are ready to actually do the integration, but again, the question didn't ask us to go that far. They just said, find me the decomposition that you would need if you were going to integrate, and there it is.